All right, so now let's do a slight variation on that. This time we have a bunch of quarters, and we're checking out their weights. And normally distributed is key. That tells us that we can use all our normally distributed tools, which there are many. Particularly tells us that the curve is nicely shaped like this. Beautiful, evenly spaced curve like that. Even tails on both sides. So that's the weight of the quarters with an average of 567 grams. So we know that the middle of it is 567. We're going to call this our x-axis. We know that standard deviation is 0.07. That's going to tell me how to translate from my x-axis to my z-axis, which measures the number of standard deviations. 0.07. A vending machine will only accept coins weighing between 5.48. I'm going to locate that on my chart here. 5.48 is somewhere here. Let's do red. 5.48 here. And 5.82. Okay. The machine will only take coins that weigh exactly those between those two quantities. What percentage of legal quarters will be rejected? Well, what percentage will be rejected? Okay, so what the hell does that mean? Let's make a picture of the area. So this is the cutoff, and that's the cutoff. Now, I take it that the area in here, the machine will accept those. It'll accept anything that's close to the real thing between that and that. So it'll accept this. It's asking what percentage will be rejected. Well, whatever percentage we have here plus whatever percentage we have here, that will be rejected. Or another way to handle it is figure out what percentage will be accepted, and then we'll subtract it from 100%. Does that make sense? I hope so. All right, talk is cheap. Let's do it. First thing I'm going to do is I'm going to try to figure out what the z-scores are. First of all, let's measure this distance in actual grams. In actual grams, by the way, this should have been x. If you want to be pedantic about that. Okay. The distance here will be 0.67 minus 548. Okay. So 567 minus 548. That's 19. So this is 0.19. That's the actual difference in grams. Now we have to take that difference and convert it into standard deviations. How do you convert it? Well, each 0.07 is one standard deviation. So how many 0.07s can fit there? Well, we'd have to divide, right? So we'd have to do that 0.19 divided by 0.07. So we do this thing by 0.07. No, not like that. That gives me 271. 271. So this is 271. Because it's on the left, I bet that number is negative. On the right side, I need to do the same thing. The distance here in actual grams will be 0.82. Take away 0.82. Take away this. How much would that be? Well, it would be 7 would be 12. It would be 0.15. Okay. Now I got to convert that using my standard deviation. 0.15 grams. Each 0.07 gram is one standard deviation. To figure out how much that is, all I do is divide. So I would divide 0.15 divided by 0.07. This is 0.15 divided by 0.07. Seriously? $2.14. There, I converted to z-scores. Now, what's the point of converting to z-scores? The point of converting to z-scores is the fact that we have this beautiful table that tells us all the any kind of area that you want given these z-score values. The way it's set up, you got one for the left side, so I'm going to try to figure out how much area is to the left on that negative number, which was, 271. So it starts off with 27. So I know that I'm going to be looking at this row here, 27. Let's highlight that. 27. And then 271. So I know that I'm going to be looking at this column, 271. So my area here is 0.0034. So the area to the left of here is 0.0034. Now this guy over here is going to tell me, now I'm going to look at the area, this z-score, and the table will tell me how much area is to the left of here. So if I look up at 214, this is going to be the row that I look at. This is going to be the column. So it's 2114. So for this, forget about that. Now we do 21, and this is not even these are negative values, so I don't want to look at negative values. Positive ones, 2, 1. So I know that I'm going to be looking at this row. 2, 1, 14, so I'm going to be looking at this column. So there it is, 98, 38, 98, 38. So 98, 38% of the area lies to the left. So I know 98% of the area lies here, 0.34 lies left of here. By subtracting those two, I can figure out how much area lies in here. Let's subtract those. So 98, 38. Minus 0.0038. So 0.98. Shoot, that was 4. It still rounds off to 98%. So we're going to call this area here 98%. The area in here would be the difference. It's 98%. So the question is asking, what percentage would be rejected? So what percentage lies over here combined with over here? If here in the middle you got 98%, then altogether the sum of that and that must be 2%. So the answer must be 2%. Now, this is not even 1%. So that's not it, that's not it, that's not it. Again, because of the software I wrote, it's incredibly accurate. It's more accurate than our actual table, which is very finite. It only goes to 3 decimal spots or 4. So they may be off a little bit, but I'm confident this is the answer, then A, because that's really close to 2%. And then we're done. Yippee-ki-yay.